one of the present by and large unquestionable and high-level physicists has conveyed his appraisal concerning the circumstance of Michio Kaku, seen for his extraordinary responsibility to the fields of actual science. He has recently confirmed that the James Webb Space Telescope has discovered 6 immense galaxies that specialists thought couldn't exist. These assessments can perhaps open up new perspectives in our scientific perception of the universe. It is, therefore, astounding and worth keeping an eye on these advancements. Kaku is an extraordinary figure in the scientific field, a physicist of American and Japanese heritage. He is seen as an ace in both outdated test physical science and quantum mechanics. Unlike some more moderate and watchful analysts, Kaku doesn't belong to that pack and has been open to the shocking eventual outcomes of the James Webb Space Telescope mission. We are truly happy that this recognized scientist has decided to unreservedly end his silence and share what can at absolutely no point in the future be denied. The energy and almost engaged tone of the glorious physicist is clear in his comments on the discovery made by the James Webb Space Telescope, imparting that this has been the feature that enjoys picked his benefit. Alongside us, he tracks down the repercussions of Kaku's disclosure of these 6 tremendous galaxies. Kaku is a scientist who has consistently been ready to contemplate new speculations throughout his life. He knows that Einstein's states of relativity and Newton's laws are missing to get the full complex of the universe. Kaku grasps that the disclosures of the new telescope might potentially propel the scientific field, notwithstanding the way that an impressive number of his colleagues have not been prepared to embrace this view. It is creating concern and restlessness about the Big Bang. Backers and foes of quantum mechanics, at any rate, find this amusing. Kaku states that the James Webb Space Telescope has uncovered the revelation of 6 enormous galaxies dating back to the earliest times of the universe. Every one of these galaxies contains a greater number of stars than our own Milky Way, despite having formed only a short time after the Big Bang. The astrophysicists who have made this discovery have termed these extraordinary cosmic structures universe breakers since they would disrupt our entire understanding of the universe. Something doesn't fit here any longer. The Big Bang Theory lets us know that the universe was a chaotic mix after the initial event. The first solid structures took countless years to form, and it took innumerable extra years for those structures to reach sufficient density and produce light. The arrangement of complex structures for galaxy models was believed to happen significantly later. Some of the recently found galaxies exceed the Milky Way in size, and their enormous luminosity shows that they were probably forming quite a number of new stars consistently, while our galaxy produces stars at a much slower rate. However, it remains problematic exactly when the first galaxies formed, and researchers have not yet been able to determine this. The most compelling thing that is clear is that initially, there may have been only single stars or small groups of stars, which eventually merged to form larger structures. Over time, smaller galaxies experienced mergers, gradually developing into larger galaxies according to established theories. Significantly, the existence of these enormous galaxies raises the question of whether the universe is much more settled than previously accepted or whether a complex structure emerged much earlier than expected. This situation is difficult to accept for some scientists, who still find issues with this model. Several factions of physical science, including some prominent physicists, firmly decline to recognize this discovery and question possible errors in the age estimates. Kaku is aware of this and also had this to say: there are a seriously large number of old and faulty theories that stubbornly persist due to the reputation of certain scientists. A significant number of these theories were only debunked when a crucial experiment revealed their falseness. Ultimately, the major work in any science, especially in actual science, rests with the experimentalists who keep the researchers ready and mindful. Honestly, on this planet, we have near zero knowledge about the legitimate origins of the universe. The Big Bang Theory was laid out in 1927 based on observations of the expansion of the universe. These data led to the conclusion that the universe started from a single point and has been developing from there forward. At the time, it was challenging for people and scientists to consider a universe with a beginning and, moreover, an end. The chance of a universe that had reliably existed and was perpetual truly seemed beyond human comprehension. Even today, scientists still face difficulties in understanding it. It is fundamental to reconsider these possibilities, as new findings fit in no way with what experts have based their theories on for a long time. The Big Bang Theory, at any rate, shows that science has demonstrated time and again that re-evaluation and openness to novel ideas are essential parts of the scientific process. There was a time when people believed that stars and planets were fixed in the universe and that these celestial bodies occupied a defined space. At any rate, we now know that everything in the universe is in motion. Planets orbit stars, moving within their galaxies at numerous kilometers per second, and entire galaxies move rapidly through the universe. The future of this motion is something we can only attempt to predict. Today, analysts are challenged to recognize unusual phenomena and understand theories that are not just guesses but rather informed interpretations that must be rigorously tested and verified by careful observations. The concept of the Big Bang arose from the observation that galaxies are moving away from each other, and this distance is proportional to their distance from Earth. This insight, known as Hubble's law, suggested that the universe has been expanding for a long time. Observational evidence, like cosmic microwave background radiation and the redshift of light from distant galaxies, seems to support this theory. However, it is significant to remember that in the past, people believed the Earth was flat and that the Sun revolved around it. They also had ample evidence for their theories until random events or technological advancements provided a clearer and more accurate picture. Right now, we are observing a similar situation. Scientists expected the new James Webb Space Telescope to confirm the theories associated with the Big Bang, yet they may have come across 6 galaxies that appeared to be massive. This prompts us to realize that science is constantly evolving and that analysts must remain open to new discoveries and reconsider existing hypotheses based on available evidence. Researchers use redshift as a tool to determine specific values in the study of the universe. Redshift, known as the Doppler effect, suggests the change in the color of light as the light sources of the observer move toward or away from each other. To understand this, imagine standing still and watching a car come toward you. As the car moves closer, you hear the engine sound getting louder. However, once the vehicle passes you or moves away, the engine sound changes. This is because the sound changes as the vehicle moves. Something similar is true for light. When a light source, for instance, a distant star, moves toward us, the light we see shifts toward bluer shades. Conversely, when the light source moves away from us, the light shifts toward redder shades. This phenomenon is called redshift. Physicists have converted redshift values into velocities and distances for evaluation in the study of the universe. However, it is crucial to note that small errors in these assessments could have significant implications. The assessment methods recently used are still under review, and it is fascinating to see what results scientists will present concerning the latest discoveries related to our universe. It is vital to consider whether they are genuinely established on redshift errors or whether some scientists are simply denying current facts. This is a question that requires thorough investigation and careful scrutiny of the data and methods used in the research. Thank you for watching the video. As always, we encourage you to post your inquiries in the comments box. If you liked the video, please remember to hit the like button and share it so it reaches more people. Get involved with the feed so you don't miss more content like this. Thank you so much for watching, and see you in the next one.